Okay, so hey everyone, today we are going to discuss about what lists are in STL C++, that is the standard template library. And before we get on to the actual implementation of it, let's just talk about what do we mean by lists in C++ when we talk about STL. So there are four types of lists. Number one being the singly linked list. Okay. Number two being the doubly linked list. Number three being the circular singly linked list, and number four being the circular doubly linked list. Now, the question arises, when we're talking about lists in C++ STL, what kind of a list are we referring to? Are we referring to singly linked list, doubly linked list, circular singly linked list, or circular doubly linked list? The list that we refer to when we are talking about lists in STL C++ is actually the doubly linked list. Okay, so whenever you study about lists in STL, always remember that we are using the doubly linked list. When we are using lists in STL, we are using the doubly linked list. Just keep that in mind. This is very important. Because when I was learning C++, while I was learning C++ and STL, I came across this question that the linked list which we are implementing here in a certain program or the list in STL, what kind of a list is it? It is actually the doubly linked list. Okay, alright. So this is a normal linked list where we have a node where nodes are connected to each other, where each node comprises of two things. One being the block of data and another block being a part of the node where we store the address to the next node. So basically linking all the nodes through the addresses. Alright, okay. And what is a doubly linked list? Doubly linked list means we can also traverse backside. Whenever we traverse through a linked list, what do we do here? In the doubly linked list, in a singly linked list, the problem is that we cannot traverse back. We cannot refer to the previous pointer, right? There is not any pointer named as previous. But in terms of doubly linked list, we have that. So we use a previous pointer, previous, okay? And this one is the next. This points to the next node, and this points to the previous node. For example, this node. The pointer of this node, the previous pointer, points to the node before this node, and this one points to the node after this node. Okay, so this is how the doubly linked list works. Now, let's jump on to the implementation of this. Again, it is all very similar to the vectors and deque. Okay, all the functions that you see in deque, all the functions, the same functions are applied when we talk about lists. Okay, now there must be a question arising in your mind that if the functions for the vectors, lists, and deque are all same, then why don't we use vectors for this? Why don't we use deque for this? Why are we just specifically writing list here? Why are we using list here? Well, for those who have studied data structures, the answer is very clear. But for those for whom it is not clear, I'm going to create a video. I'm going to give you a link in the description. But for now, let's just understand this. So pushback function, it pushes to the back of the list. Push front pushes to the front of the list. So I have pushed back here 4 elements, that is 10, 20, 30, 30. I push 0 in the front of the list. So 0, 10, 20, 30, 30. Okay. Now, pop back. You know what pop back means. We remove this element. Pop front, we are removing this element. So what do we get as an output from here? So I'll just run this program and we'll see. We should get 10, 20, and 30. And see, we get 10, 20, and 30. Similarly, all the other functions, all the other functions, insert, erase, empty, clear, are exactly the same as that of deque. Alright, there is no difference in the working of those functions. So that is it for this video. Thanks for watching, guys. I hope you like the video, and if you like the video, then hit sub, and goodbye.